to look at a number of integration problems. And the first example we want to look at is how to integrate the integral of 1 to 3 to all over the square root of x dx. And this, I can also comfortably write it as this. I've put 2 outside because I know that 2 is a constant. And the integral rule says, what do I do to the power? I increase the power by 1. So negative a half plus 1 is a half. So it is x raised to power half. And then I divide by a half. And then I put the limits of integration. And you've seen that I've not put in the constants of integration because I did not see the need to do so. And this automatically becomes a half. 2 divided by a half. I'll leave it as it is now. It is 3 to power half minus 1 to power half. 2 divided by a half is the same as 2 divided a half, which is 2 times 2. And this is 4. So the answer will be 4. Then the square root of 3 minus 1, which I'll comfortably leave out for you to get a calculator and be able to key in those values to see what you get from that computation. After all, even if you are to leave it that way, I don't think it will affect anything so long as the answer is okay. The second integral we want to look at is 4x cubed dx, which I can write as 4, the integral of x cubed dx, which will basically be 4 x to the power 4 over 4 plus c, which is x raised to the power 4 plus c, which is a constant. Because this is an indefinite integral, we have to put the constant of integration. So that's another example that we have looked at. The third one is a simple one also. We want to integrate from negative 1 to 11 x raised to power 1 to power 1 over 11 dx. And I want to reduce this by letting u is equals to x plus 1. And then I have du dx as equals to 1. So if what we have here is that dx is equals to du. So I'll be having the integral of 1, negative 1 to 11 u raised to power 1 over 11 du. What do you do to the powers? You increase the power of, by 1, so it will be 1 over 11 plus 1 divided by 12 over 11. And that's what we get from that. And so, because our integral was originally in terms of x, so I'll have x plus 1 raised to power 12 over 11. Here I have divide by. So if I divide here, it's like I'm taking 1 all over 12 divided by 11. And then I have negative 1 to 11. And so this will be affected. This will be 11 over 12. This is 12 raised to power 12 over 11 minus negative 1 plus 1 is 0 raised to power 12 over 11. So the answer will be 11 over 12 times 12 raised to power 12 over 11. Is the integral of 12x squared plus 4 divided by 4x cubed plus 4x dx. So what we do is we let u be equals to 4x cubed plus 4x. So du dx, du divided by dx is 12x squared plus 4. Then I have dx is equals to du divided by 12x squared plus 4. So now I'm going to substitute u and dx into the original equation that I have, and I see how my problem simplifies. So I have 12x squared plus 4 over u times du over 12x squared plus 4. And that simplifies to du over u, which I know it is the ln of u plus a constant. I'll put a constant when there are no limits of integration, or it's an indefinite integral, and that gives me the ln of 12x squared plus 4 and then plus c. In other terms, can put it in a simpler manner to make it look a little bit more appealing to each one of us. So that's what we have. In the final solution that we'll get in that equation number 4 that we have solved. And this is the integral of x raised to power 7 plus 3x raised to power 4 plus 2x squared dx. Remember, because you're integrating, you just increase the power by 1, you divide with the new power. You increase the power by 1 and you divide by new power. You increase the power by 1 and you divide by the new power. That's basically what you do with the change of color that I've done. So this is x raised to power 8 over 8 plus 3 over 5 x to power 5 plus 2 over 3 x to power 3. And because it is an indefinite integral, you introduce a constant into the integration that you have. So that's what you get in that integral that you have. And then we have pi sin or sine of x over 2 dx. So what I'll do is I let u be equals to x over 2, then du over dx. Du over dx is equals to a half. Dx is equals to du. So then I'm going to change my equation slightly to make it easier for me to integrate 0 to 5 pi. Then it will be sine of u times 2 du, which will be minus 2 cos u. But before I can substitute my limits of integration, I have to rewrite back in terms of x. Otherwise, I have to do a full transformation of the equation. It will be minus 2 cos of x, not pi, cos of x over 2. And it's 0 to 5 pi. And that will take me to another level. And that gives me negative 2 cos of 5 pi over 2 minus cos of 0. And whatever solution you get, and I think this will give us 2 as the answer, because yes, I think cos of 5 pi will be 0, because this is an odd one. And